I am going to touch a problem in properties of pure substance. So you already know what is a pure substance. That is a combination of two phases of substance which are in same in chemical composition. Here in the pure substance, we have a two combination. One is saturated steam, another one is a saturated liquid water. There is a mixture of two phases that forms a pure substance. We are going to find the properties of the mixture. Now we move to the problem. A vessel of volume 0.05 meter cube. Consider this is a vessel. So this consider this is a vessel. This vessel volume is equal to 0.05 meter cube. Okay. It is a mixture of saturated water and saturated steam at a temperature of 245 degrees Celsius. So this vessel comprises of that is a saturated liquid water and saturated steam at a temperature of say it is a 240 degrees Celsius. The volume of vessel is 0.05 meter cube. Here, the next one is the mass of liquid present is. So, the mass of liquid that is M of F that is present is that is a 10 kg. In some book, it can be represented as M of L. Here, for our Canin, we represent it as M of L, which is equal to 10 kg. Here, the mass of steam is not given, the pressure is not given. The only given parameter is the temperature is 245 degrees Celsius, the volume is 0.05 meter cube, and the mass of liquid is 10 kg. Okay. The next, what are the parameters that you are going to find? So next parameter, what the parameter that you are going to find? So first one is the pressure. So at what pressure the vessel exists. Second one is the mass of mixture. Then third one is that is the volume of specific volume of the mixer. Fourth one is the enthalpy of mixer. Then fifth one is entropy of the mixer. Then sixth one is internal energy of the mixer. So these six parameters we are going to find. So before we enter into the problem, let us know what is the condition of the mixer exists with the help of a TV diagram. So in a TV diagram, you can draw two axes. One is y-axis. Y-axis is the temperature. Then x-axis that is nothing but the specific volume. In the TV diagram, we have a saturation curve. So this is called as that is a saturation curve. So in a saturation curve, this point is nothing but the critical point. So this curve that is called as a saturated liquid curve. Then this curve is called as a saturated vapor curve. Here in the TV diagram, this we draw the temperature line. So this is the temperature line. You can assume there is a given temperature that is a T is equal to say that is called as a 245 degrees Celsius. Here in the TV diagram, the pressure line is like this. This is called as this is the pressure line, constant pressure line. Okay, this is a constant pressure line. This constant, so P is equal to, we can say that is a P is equal to constant. The temperature is 245 degrees Celsius. Here you can identify which condition the mixer is exist. So in a problem, it is a clearly specified. It is a mixture of saturated water and saturated steam. So it is in a mixing condition. So normally mixing condition lies in between the saturated that is saturated liquid curve and saturated vapor curve. So at what exactly it can exist here? That is the m of liquid is only given, so which is equal to 10 kg. Then mass of steam that is not given. So if we given mass of liquid and steam, we can find the condition of the mixer where the x is. So that can be calculated from the formula x is equal to m of g, right? So x is equal to, you can write I can write x is equal to m of g divided by that is called as a m of f plus m of g. By using this equation, you can find exactly where the mixer exists, whether the x is in this point or this point or this point or any point which it exists. So for that we know mass of steam. How we find the mass of steam? Here the temperature only given, mass of liquid is only given. And one more thing in the problem, so at what exactly the mixer exists is the exactly mixer exists at a 245 degrees Celsius, because the problem is 245 given temperature is 245 degrees Celsius and the condition is given as a mixture of saturated water and saturated steam. So in this area the mixer exists. From this one here you can write there is x is equal to 0, here the x is equal to 1. So in between these two lines the mixer is exists. How we can find this? Okay, so we move to the problem. We need a mass of g. So first one we need a mass of g. What is that is called as there is a mass of steam. How we can find the mass of steam? How we can find the mass of steam? So we can interrelate these three properties here. then we can find the mass of steam. So what are the parameters that you are going to interpolate? So the three parameters we are consider, one is nothing but the volume, the next one is the specific volume, then third one is the mass. We can interrelate these three properties. Here already you know that is equal to mass is equal to volume divided by specific volume. Otherwise we can from the density specific volume equations, uh, based from the specific volume equation, the specific volume is equal to volume divided by mass. Otherwise we can say volume is equal to mass into specific volume. Otherwise mass is equal to volume divided by specific volume. We have some three relations. From the three relations we are going to find the mass. Here how in the condition you can note that total volume is given, mass of liquid only is given. We don't know the mass of specific volume of liquid or specific volume of steam. Otherwise I can write in a clearly note that. So this is considered for total, v total, v total, v total. So it is for total. We can write the specifically for each thing. Here specifically for, so specific volume of there is a liquid is equal to volume of liquid divided by mass of liquid. Otherwise what total volume of liquid is equal to, it can written as mass of liquid into specific volume of liquid. So this is a case for liquid. And for steam, so specific volume of steam is equal to volume of steam divided by that is the mass of steam. Otherwise volume of steam is equal to mass of steam into that is a specific volume of steam. So this case is for steam, this case is for that is called as a liquid. So from that we know only one thing, this is for total mixer. This is for total mixer. From these three relations we only know only certain part. So what are the certain part we know? So we know the total volume, then mass of liquid. These two parameters are we are only know. So we unknown the values like a specific volume of liquid and a specific volume of steam. These three parameters we unknown, totally we unknown. So how we can find the parameters? How we can find? So this is the first part of the problem. So this can be find with the help of a steam table. So already we studied about the discuss about the steam table. So in the steam table we are having a number of tables. First we know saturated water and steam table. Okay, here saturated water and steam, that is a temperature table. So in a temperature table the first column represents the temperature. So now the temperature given is 245 degrees Celsius. So in a 245 degrees Celsius, what about the condition of the steam? You can direct taken from the steam table. For our convenient, I just give a screenshot for the steam table in the presentation slide. That's right. Okay. Here I can given the steam table for a particular rate, there is a 245 degrees Celsius. For our convenient, I can given the screenshot of this value. So first we know the total volume is equal to volume of liquid, total volume of liquid plus volume of gas. Okay. Here we need to find the volume of liquid and volume of gas. Otherwise you have to find mass of total is equal to mass of liquid plus mass of gas. Then how we can approach these conditions? You know the volume of liquid, first you consider this volume of liquid. So this volume of liquid is equal to, already we have a relation mass of liquid into specific volume of liquid. Okay. Here the mass is given, which is equal to, in a problem the mass is given as, say, that is a 10 kg. What is the here it is a 10 kg. What is the specific volume of liquid? So at a 245 degrees Celsius, so this is the value given a specific volume. So directly that is Vf is equal to what? 0.00124. So here volume of liquid is equal to 10 kg into 0.001240. The unit is equal to meter cube divided by kilogram. So kilogram gets cancelled. Finally, the volume Vf that is equal to 0. Finally, after substitution, we are getting volume 0.01239 meter cube. Then Vf you are fine. So what about the remaining parameter? Then you find a Vg. How we can find Vg? Vg is equal to total volume divided by the volume of liquid. So total volume that is equal to 0.05 meter cube, already given the problem. The volume is equal to 0.05 meter cube. So 0.05 minus 0.01239. From that you find the total volume that is equal to Vg is equal to 0.03761 meter cube. Okay, here you find the total volume of liquid and total volume of what? Gases. So from that you are going to find the mass of the particular substances. Okay, here again you from the Vg you can find that is a Vg is equal to there is a mass of G into specific volume of G. Okay, here Vg that you already find, then specific volume of G you can taken from the steam table. So mass of steam which is equal to total volume of steam divided by specific volume of steam. Here the total volume which is equal to 0.03761 divided by specific volume of steam that is equal to 0.054606. Finally, you are getting a mass of steam which is equal to 0.688. This is the mass of steam. This unit is nothing but kilogram because the unit is equal to meter cube. Here the specific volume is equal to meter cube divided by kilogram. So meter cube getting cancelled. Finally, you are getting unit is the mass of G is equal to 0.688 kilogram. Then next parameter is you are going to find the what is the condition of steam exist, because the mass of steam was found, then mass of liquid that is already given in the problem which is equal to 10 kg, then volume specific volume of steam was found, then specific volume of this is specific volume of liquid. We have a total volume of liquid and a total volume of volume of that steam. So for all parameters Vf, Vg, specific volume of F and specific volume of G, and mass of F and mass of G. So all these 6 parameter you know. So these six parameters are essential. Already given this parameters with the relation of volume, specific volume and mass. Okay. Here we are going to find the quality of steam. So this is the quality of steam that can be represented by the term that is called as a dryness fraction. So X is equal to mass of steam divided by mass of liquid plus mass of steam. The mass of steam that is equal to 0.688 divided by mass of liquid is equal to 10. Then mass of steam is equal to 0.68. Finally, after substituting, we are getting the steam quality which is equal to 0.064. So which is equal to 6.4 percentage. So this is 6.4 percentage. So this can be known with the help of a TS plot, TV plot. Okay. So this is the temperature, this is the volume. So here it is a saturation curve. I think it's not working at that place. Okay. Here the steam that is located at some specific point. So this is at a point. So the steam that exactly located at 6.4 percentage. So that is X is equal to 0.064. So 6.4 for this steam is located at a particular point. Then you have to find the specific enthalpy and specific internal energy and specific entropy at that point. So from the table already you know, from the diagram you know that, so this is a point, you know, so this is the VF line, you know that this is a VF line. So at the 245 degrees Celsius, this is a VF, that is 0.0001240. Then at a particular point, this is called as a VG. So in between this value, this is called as VFG. So in between this one is called as VFG. But we need a point, we need a value at this point. This is the point we need. So this is the point. We consider this point is nothing but Vx. We call it as that is the x. We need a point at this point. How we can find? So this can be find. Already you know this value Vf you know. Then next VFG you know. But in some part of VFG you are going to find. So that can be calculated by, so Vf is equal, sorry, Vx is equal to this Vf you already know. So the Vf plus VFG, some part we can add, that is called as a x. So here I can written as, so V at the specific element at some point x is equal to Vf plus x into Vfg. Okay. Similarly, we can find all these three parameters. So in a steam table, you know, have a value. So better we can take the value from the steam table. Here you can note that that is equal to Vf is equal to, sorry, V at x. V at x. So V at a particular point, that point is called as a x, or just into V is equal to Vf plus x into Vfg. So which can be written as Vf plus x into Vg minus Vf. Here the Fg represent, there is V of Fg represent Vg minus Vf. So in a steam table, Vfg is directly given. In some problem, Vg and Vf only given. From that, we are going to calculate a Vgf. So Vf already you know 0.0012 something. What 1240, 0.054606. 1240 plus x already you know 0.064 into Vg, that is a 0.054606. 44606 minus 0.11240. After substituting the value, you can get the V, that is equal to 0.04654, that is a meter cube per kilogram. You can find the V. Then next one you can find, that is called as a H. H is equal to HF plus X into, that is called as a H of G. Here where you can find the HF? At a 245 degrees Celsius, the HF is equal to 1.0 1061.6, HF is equal to 1740. Here H is equal to 1061.6 plus x is equal to 0.064 into HFG is equal to 1740. After substituting this value, you are getting the H is equal to 1172.77 kilojoule per kilogram. Similarly, you can find the S. So S is equal to SF plus X into SFG. Here SF, here SF that is equal to 2.748, SFG is equal to 3.358. 2.748 plus 3.358. X is equal to 0.064. After substituting this value, finally you will get S is equal to 2.9623 kilojoule per kilogram Kelvin. You can find the internal energy also. Finally, you can find the last parameter, that is called as the internal energy. Internal energy. So internal energy, that is not given in the steam table. So in steam table we are having a volume, enthalpy and entropy. These three values are given. So internal energy is not given. So how we can find the internal energy? So from the relation enthalpy equation, H is equal to, that is called as a U plus PV. Here U is equal to H minus PV. So H you already find. So H is equal to 1172.77 minus pressure. The corresponding pressure in the condition is equal to 36.523 bar. So first one we are going to find the pressure, but which is not required. So we leave it. Now we can use this because the first condition is the pressure. So at the condition the pressure is equal to 36.523 bar. So here bar. Here 36.523 bar into what is the specific volume? Specific volume we are given. So 0.004654 meter cube. It is not working. So it is given a meter cube per kilogram. So PV. Here the value, that is a bar and meter cube per kilogram, that is not able to find. So bar into meter cube divided by kilogram. So which is not able to multiply that. So for converting bar into Newton per kilonewton per meter square. Already you know that is 1 bar is equal to 10 to the power of 5 Newton per meter square. So which is equal to 10 to the power of 2 in kilonewton per meter square. So 36 point, what is the pressure? That is 36.523. 523 bar is equal to 36.523 Newton per into 10 to the power of 5 Newton per meter square. So it's kind of 36.523 into 10 to the power of 2 kilonewton per meter square. So this is the value you are going to substitute, is equal to pressure. So you can substitute that. Here 1172.77 into, sorry, minus this pressure, that is a 36.523 into 10 to the power of 2 kilonewton, sorry, this is not working, kilonewton per meter square into, that is 0.00, that particular specific volume, the unit of specific volume is meter cube per, that is called as a kilogram. Okay. Then after substituting this value, finally you are getting the internal energy, that is U is equal to 1155.78 kilojoule per kilogram. Okay. So we find all these parameters. Here the pressure is given, then mass, total mass, which is equal to, already given the total mass, which is equal to combination of that liquid plus steam, that is equal to 10.668 kilogram. Specific volume we find, this is specific volume, total specific volume, that is the third one. Here the enthalpy, which is equal to fourth one, entropy is the fifth one, in the internal energy, that is called sixth one. So all the 6 parameters are fine. Okay, thank you.